Good morning, everybody. We are going to be talking about function notation, vertical line tests, and graphing in today's video. So get ready for all this information that you already know that we're just going to put together. All right, the first thing is a function notation, and we have done function notations last semester actually, and basically it helps us know what number to substitute it into the problem, and then the answer you get is the answer you would get if you were to substitute in that number. So for example, f of 4 equals 8. Let me write that down because I want to make sure you guys can read it correctly. F of 4 equals 8. That's how we read it, which means that x equals 4 and y equals 8. Okay, so when I substitute in x equals 4, my output, what I get out is going to be 8. Right? So in example 1, it says write in words what the following means. So here it says f of 6 equals 1.5. And really what that means is when x equals 6, you get 1.5 as your answer. Okay, so when you put it into the function, you're saying like x equals 6 and the output is going to be 1.5. So we call the 6 the input and 1.5 the output because that's what we get out. All right, so let's use these concepts. Here it says if x equals 4, find f of x equals negative 8 plus x. Really what they're saying is find f of 4. So we know that x equals 4. And so we have negative 8 plus, and instead of the x, I'm going to go ahead and put 4 in there. And when I simplify, I get negative 8 plus 4, which reduces to negative 4. So f of 4 equals negative 4 is my final answer. All right, let's look at the next one. If x equals 2.3, find f of x equals 2x plus 4. So here what they're saying is find f of 2.3. Once again, x is 2.3. So we have 2 times, instead of x, I'm going to write 2.3 plus 4. We never touch the left side. We only work on the right side. So 2 times 2.3 is 4.6. Plus another 4 is going to give us the 8.6. So final answer is f of 2.3 equals 8.6. Done. All right. Now, not all equations are functions. For something to be a function, for every x, there can only be one y value. So let's look at some of these points that we have. Our idea is the following set of points a function? Either way, state the reason. So if they are a function, we're going to state why, and if they are not, we're going to tell you why. All right, so if you look at the first one, when I say 2, I only see a 3 for an input. When I say 4, I only see a 5. When I say 6, I only see a 5. When I say 9, I only can say 7. So those are what matches each other. So is this a function? Yes, it is. These points are a function. And the reason is because for every x value, there is only one y value. Now, some of you might be thinking, but when you say 4, the output is a 5, and when I say 6, the output is a 5 as well. That's okay. It's kind of like you going to a vending machine and you get Doritos and your friend gets Doritos. The machine is still a function. It works well. The problem is when you put money for 1 chips and you get 2, that's when the machine is broken. Like I put money for 1 chips and I get Doritos and I get hot Cheetos. Wah, wah, the function doesn't work. All right, let's look at number 5. So when I say 5, I can say 8 and I can say 3. So because of this right here, I can say that no, these points are not a function. Oops. Okay, and the reason is because for x equals 5, there are 2 y values, and that is 8 and 3. So 1x should not have two things it's approaching, and in this one it is. So let's look at number 6. We have 4. When I say 4, I get a 6, and there's a 4 and a 6 there as well. So really that's the same situation. When I say 5, I get a 7. When I say 8, I get a 5. This is a function because for every x value, there is one y value. All right, let's keep going. Ooh. All right, so when looking at a graph and being asked if something is a function, the easiest way to check that for every x there's only one y is by using the vertical line test. So the vertical line test pretty much, let's say that this right here is the function. The vertical line test says that if I run one vertical line, then the vertical line should touch the graph only in one spot. And as long as that continues for all the vertical lines, then it is a function. So that line right there is a function. Same thing for this quadratic. Here's a graph that we have, and if I run one vertical line test and continue doing that along its graph, every time I do a vertical line test, as long as I'm touching the graph only in one spot, I am a function. Now here are some examples of not functions. Here's a vertical line test. It's touching the graph twice, therefore it's not a function. Same thing here with the circle. The line is touching the circle in 2 places when it should only be touching it once. Therefore, one false answer allows us to say it's not a function. All right, let's look at number 7. State if the following graphs are functions or not, and state why or why not. So if I run a vertical line test, it looks like I am pretty good. Every time I'm running it, it's touching it only once. So I would say yes, the function, or actually the graph passes a vertical line test. And then in number 8, let me just run 1. Ooh, I touched it once, twice, and 3 times. So since that one line touches it 3 times, we would say no, the graph does not pass the vertical line test. All right. Let's look at a quick review. Finally, let's review graphing and graph the following. So here we have y equals 3x minus 4. Now, when I look at it, as soon as I see that the power is 1, I know that this is a line. In example 10, as soon as that I see that little squared, I know that this is going to be a parabola, a quadratic. Having that shape is important to us because then it helps us figure out what the shape is going to look like or what I should be expecting. So what I'll do is I'll plug in some negatives, some zeros. So I'll do -2, -1, 0, 1, and 2 just to see if I can get an idea what the graph looks like, and I substitute it in. So 3 times -2 minus 4, well, that gives me -10. So here's my first point, -2, -10. 3 times -1 minus 4, that's going to give me -7. So I'll plot -1, -7. 0, 3 times 0 minus 4 is just -4. So I'm going to plot 0, -4. 3 times 1 minus 4 is going to give us -1. So I'm going to plot 1, -1. And then we have 3 times 2 minus 4, which is going to give us the 2. So I'm going to plot 2, 2. And I can get a sense of what my line looks like. And here's how we graph a line. Now for the other one, we know that we have a quadratic, so I'm just going to go ahead and put some numbers in there too. You can also use your graphing calculator. So I'll put it in there. 2 times 2 squared, -2 squared, minus 1. Well, -2 squared is 4, times 2 is 8, minus 1 is 7. So we're going to plot -2, 7. negative 1. So 2 times negative 1 squared minus 1. Negative 1 squared is 1 times 2 is 2. Minus 1 is 1. So we have a point at negative 1, 1. 2 times 0 squared minus 1. Well, that whole thing is 0, so it's just minus 1. So 0, negative 1. We have 2 times 1 squared minus 1. So that gives us 2 minus 1 is 1. So we have 1, 1, which is good because it's symmetrical. And we have 2 times 2 squared minus 1, which is also going to give us a 7. So we have 2 to the comma 7. And then we can graph our parabola. Try to make it a U as much as you can. There you go. And that's how we graphed any of those equations from back in the day. Just a quick review. All right, guys, I hope that was helpful. Looking forward to seeing you in class. Bye.